So what we got here is, this is Algebra 1, right here, Algebra 1, Semester 2. This is Unit number 1, which is on exponents, or exponents. And this is the second lesson, Adding and Subtracting Polynomials Practice. Right? This is all found under creatormath.com. And you're going to click into the Algebra tab to get to this exact assignment. Scroll down and you'll find this by title, right? You'll find the Exponents unit and you'll find the lesson Adding and Subtracting Polynomials. Here are the directions for us. Copy the following problems 1 through 10 into your composition book on the correct pages according to the table of contents with the notes for these pages from creatormath.com. If you have any questions on that, hold them till the end and I'll answer all those for you if you don't know where to find those pages or how to find that table of contents, all right? The first thing they ask us is, what does CLT stand for? CLT is a concept that you should have heard by now in your math career. It stands for combine like terms. Now, just some information. In my multiple choice questions that I go over here, my answer always appears up at the top. When you're doing the assignment that you've got, it's going to randomize these, so yours won't be always at the top, right? Mine is, though. CLT stands for combine like terms, and that's what this lesson is explaining a lot of. We have this idea in algebra of, apples get combined with apples and oranges get combined with oranges, and you'll hear that expression. And I don't know if it helps us much because I don't know how many times we're combining apples and oranges, but just the idea that like terms are things that go together versus things that don't go together, right? We want to separate things into categories. Algebra has its categories. All right. The first problem they're giving us to work on is this one here. It says x squared plus x cubed, right? This is a little bit of a warm-up and a little bit of a trick. We have two bases that are the same. That's good. We got x and x. That's good. But because these powers are different, see how this is a 2 and this is a 3? These are not like terms. Not like terms. Right? These are not like terms. When we have a different power on those, that's what makes them not like terms. And so the trick of this whole thing right here is they're kind of tricking us in a way, or they're sort of leading us into, are we going to make a mistake or not? These cannot be combined. The best you can do is just rewrite these. And notice we're adding these. We're not multiplying. If you look at the other lesson, prior lesson, we multiplied. This is an addition symbol. The operation between these is addition. So these cannot be added. They are not like terms. So this remains x squared plus x cubed. And so this first answer here, remember that for the computer they're going to use a caret symbol. X caret 2 means x squared. And just for your information, Shift 6 is the caret key on your keyboard, right? So these are not like terms. They cannot be combined. They just sit here together. That is the lowest form they can get to. There is no simplification beyond that. All right, with that said, now they're going to start to give us some of these that can be combined. So we have a 2x and a 3x, all right? This is literally 2x's and 3x's. How many do you have total? You have 5x's. That's how many you got, right? This is not multiplication, this is addition. And because they're both to the power 1, we can combine them and we get 5x to the power 1. 1 is one of the 3 invisible ones, right? There's a 3 invisible 1 rule. If you have an x, you have 1 times it, you have it to the power 1, and it's over 1. But we don't say all that. We just say x. There's always 3 invisible 1s around every variable and around every number. So that's it, 5x for this one, all right? Let's go to the next. It'll get a little bit more complicated here. Here we have 5x squared minus 2x squared. These two things are the same. They're the same variable and the same power, so these are like terms. These can be combined. If we're going to have 5x squareds minus 2x squareds, we're left with just 3x squared, so 3x squared. All right, they're getting a little bit more complicated here. Now we have an x cubed. We have a couple of x squareds. Here's one. Here's one. These are like terms because of the x to the power 2. They both share that. Here's an x to the power 1 and an x to the power 1. So these are like terms here. So we're going to combine these two, and we're going to combine these two. This one can't combine with anything. It stands alone. So we get an x cubed. It just repeats. A 3x squared and a 2x squared is plus a 5x squared. Okay? And a 6x minus 5x leaves you with just one x. Right? 6 x's minus 5 x's leaves you with 1x. And so we're looking for x to the power 3 plus 5x squared plus x to combine like terms for this. Sometimes I like to use different variables. This has a c, a d, a cd, a c squared, and a c squared. Those are like terms. I see a d squared here, right? So these, let's connect those. I see a d squared here. These connect. And then there's only one set of 3 CDs, right? That's going to stand alone in this whole thing. Let's start with 8c squared, and it's plus a plus here, 6. So 8 and 6 is 14c squared. So I'm going to start with 14c squared. I'm going to move to the CD, minus 3CD, and this is a plus here, and I'll show you that in a second where that can get more complicated. So I'm going to say minus 3CD. And then this last one is 7d squared minus 3d squared. 7 minus 3 is 4. So this should be plus 4d squared. All right, this first option here. 14c to the power 2 minus 3cd plus 4d to the power 2 is this one here. That's what we wrote. All right, now let's get a little bit more complicated. Here's the thing. Anytime you have a minus sign outside of a parentheses, this is like saying minus 1 times this quantity. All these signs have to change. So the way I like to do this is to rewrite the whole thing. I like to say this is a minus 1 times 2s squared plus 3st plus 7t squared. And this gets distributed. So you multiply it across these terms inside the parentheses. Well, a negative 1 times a 2s squared becomes negative 2s squared. A negative 1 times an st becomes a negative st. And a negative 1 times a 7t squared becomes a minus 7t squared. So the negatives get distributed across those. Now, we don't have the minus here anymore. We have a plus. So go back to this one. We have an s squared here and an s squared here. These two are going to combine. So 3s squared minus 2s squared leaves us with 1s squared. We have a 2st here minus an st, so that's going to leave us with 1st. A 5t squared here minus a 7t squared goes negative, so it's going to leave us with minus 2t squared. And if this is done right, let's see, s power 2 plus st minus 2t squared, this one right here. Right? That's one of the most complicated situations for students. It just freaks their mind out. If you have a negative in front of something, you know, an x plus a y plus a z, right? This negative gets distributed across those. And it can be even more complicated if you have a negative in front of an x minus a y minus a z, right? This becomes negative times x is a negative x. Negative times negative, though, now this becomes a positive y. Negative times a negative, this becomes a positive z. And this now switches to an adding situation there, right? So that's one of the most complicated. Let's go here. Let's look for like terms. Like terms here are there's an a squared and an a squared, so I'm going to combine those. 5a squared and 3a squared is going to be 8a squared. I see an AB and an AB. This is 7AB minus an AB, going to give us a 6AB. Minus 3B squared and minus 3B squared here, and a minus 6B squared. So those combine to be a greater negative, minus 9B squared. So I'm looking for 8A squared. or 8a to the caret 2, which means power 2, plus 6ab minus 9b caret 2. All right, let's do the last one. The last one's one of these change the signs. This negative 1 is going to get multiplied across these. I'm going to do it a little bit quicker. I'm going to say plus. There's a minus 5x squared now. Negative times a negative is going to be a positive, so positive 6xy. Minus times a positive is a minus y squared. Now I'm going to combine the negative 2x squared here with a negative 5x squared here for a negative 7x squared. I have an 8xy plus a 6xy is going to be a plus 14xy. There's no y squared in this, but there's a minus y squared here, so it just hangs on for the ride. And it looks like I got a minus 7x to the power 2 plus 14xy minus y to the caret 2. All right, so that's it. It's not that many problems this time for this lesson. Go ahead and find everything at creatormath.com. Make sure you're pulling up the notes for the comp book. Those go on the proper pages, and these problems go on the proper pages too.